Oh boy, it's been a couple of days, huh? Yeah, I took a break. Sorry about that. I just, I don't know. I didn't feel like continuing work on Alloy on stream anymore. It just, it felt boring, both for me and for everyone watching. So today we're gonna work on something new for Leaf again instead of Alloy. But before we go to that, let me quickly catch you up on what happened. So first of all, I spent the past 3 days writing a new library called Font Discovery. It is a library that allows you to search and list fonts matching a particular set of properties, system fonts that is. So it'll give you, for a particular query of, say, font family and slant and weight and stuff like that, it'll give you either a list of matching fonts or one most matching font from the system, and then you can ask it for the file path to that and use the file path to do whatever your in-engine font loading and rendering and whatever. So this effectively allows you to use user specified system fonts in addition to fonts you actually ship with your gamer engine, and that makes it particularly useful for applications that are not bundling everything all the time. So if you want to write a word processor and you're not using the UI toolkit that already provides a font picker for you, there you go, now you can do that, and that's pretty cool. So, yeah. So that's one part of what I did. Other than that, I did a bit of work on Alloy, just a small bit. So here's a little demo, same demo we had before. And I improved the text field, so now you actually have a visible cursor. I'm not sure how well that shows up on stream. Let me see. Yeah, there you go. It's a closer view. So there's now a cursor that you can move around and, edit like you would normally. And it also handles clipping correctly and moving the cursor or the text off screen if it's too long. Stuff like that. The switch also looks as it should now. And yeah, that's pretty much it. I didn't do that much, just a couple of small fixes and improvements. What does bother me a lot though is the font rendering. It's really not good. Font just makes very blurry, gross glyphs, and I don't like it. So I've been thinking about how to improve that situation. And
Good evening.
good evening, Finn. And in general, text rendering is a huge problem space. And it would be fantastic if I could collaborate with a couple of people and, put together a text suite. So that would involve, character layouting. So left to right, right to left, bidirectional, top to bottom, bottom to top, text orientation, uh, line wrapping, of course, and kerning and ligatures and all that kind of stuff, in addition to the actual glyph rendering. But yeah, that's a huge task, so I'm hoping I can either join an existing project or get some other people on board to work on that. But that's for another time. Today will not be an Alloy day, today will be a Leaf day. So let's boot that back up. It's been a while. In the meantime, I've also tried to, also kind of fell into a hole of not knowing what to do with Leaf Eater, because, a lot of the engine that's required is already done. There's not that much that needs to be done, and I should really get to world building and writing and all of that good stuff. But I have no idea how to do that, so I've been kind of fretting on that front, and I really should just sit down and write some stories, but that's not programming streaming, so I can't really do that on stream. So tonight we're going to do something different. we're gonna be doing a new lighting system. So for those of you who were there, you might remember how I did the lighting system on previous streams. And essentially the way it worked was that you would send an array of lights to the GPU via uniform buffer. Please. So you would have an array of light attributes and whatever, which is positioning and sizing and types, the kind of light and the color of the light and all of that stuff. And then when you actually, oh right, zoom out again. Whoops, thank you. So now when you actually render anything, so you have some kind of geometry here, I don't know, maybe something like this. Then in the fragment shader, so for each fragment that's being rendered, you correlate that fragment, gross. Let's see. Let's say, for instance, this here, not filled, you ass. It's this here, and then you look up whether. Then you, from all the lights, you build signed distance functions. And signed distance functions are basically implicit, and they, what you do is you evaluate the signed distance function that you build implicitly from the information of the light at that point. So, for instance, if you have a sphere light, a signed distance function is kind of analogous to a gradient. So let's do a radial gradient here. So for instance, let's say we have a light here, and we're going to make it like this. So you get a signed distance function, something like this. That's a bit different, mostly because the signed distance function actually yeah, this is not a good example. Let's see, can I maybe do something that's more close to that? Do you have a preview for that? Something. Let me just quickly build something. Okay. This is not great. So, wait, what? Pattern. No. Oh my god, what am I doing? Okay, that's, give me a second. Okay, let's say we have a thing like this. There we go. Okay, you can't see shit, but alright. So, signed distance function is a function that gives you for position, for coordinate, it gives you a signed distance value. So in our case here, the blues will be negative values and the reds will be positive values and the yellow will be 0. So on 0 it's exactly on the corner of the light, I guess, and red it's outside. So now at this point you're looking at this and you want to know whether you light it, so you evaluate this function and you get some kind of positive value, so you know it's outside of the light's effect and you don't shade it. Otherwise, if it's inside, you can apply some kind of transformation to that value to get some kind of lighting density or effectiveness, I guess, or attenuation, I guess. So, that's how signed distance functions worked and how it worked before. The problem is this is a very, very costly operation. Especially fragment shaders are very costly to do a lot in. On Intel hardware, for instance, it's very difficult to get anything done because it just doesn't let you do a lot. So you would try to minimize the number of steps you do in a fragment shader. Because for each pixel that you shade, or each fragment, or each pixel might have multiple fragments, and for each fragment you have to evaluate all of these functions implicitly, and that might be very expensive. You might have, you need to build rotation matrices and do all kinds of stuff, so that's not cheap. And
I
it's
know. It would also be interesting if you cover all the other topics besides programming, even if it doesn't flow like programming.
okay. I'll have a. I mean, I've covered drawing, so I guess writing wouldn't be too far out of it. It's just something I've never done, so I'm not sure how well it will go. But I could give it a go. Also, Repsinich something says on Twitch. How's it going? I've seen your channel. Your streams get better every time. Keep it up. I'm going to design a custom overlay for your streaming. Ooh, thank you. Take a look. The reference on my Twitch profile's pic. Okay. Do I have the wrong category right now? Hold on. I need to check. Twitch. Twitchity Twitch. Where's my thing? Dashboard. I do have the science technology dashboard category set, so I should be fine on that. For some reason the programming tag got cleared though for game development. Let's see. There we go. Okay. Update. There we go. Good. Okay. All right. So that's how it worked before, but it's quite costly and it's also difficult because you can't easily build these kinds of functions on on user side. So if you have a new kind of light that you would like to present, you need to build a new shader function and incorporate that into stuff. And it also doesn't allow you very complex things like texturing. So you can't easily apply texture to your light to make it brighter or dimmer in certain areas or whatever you want. So this is quite limiting and quite inefficient. And there's a much easier, ironically, much easier and much more performant and much more expressive way of doing things, which essentially means it's better in almost every respect I can think of. And the idea of this is to do a sort of a inverted deferred rendering kind of thing. I'm not sure what I should call it yet. So the idea is that you have two stages of rendering. So, the second stage is your normal stage where you render, your actual geometry. But in the first stage, what you do is you say, let's make, can I draw a polygon here? There you go, fill it with the foreground. Let's make that yellow. There we go. So for instance, in the first pass, you would like to have some kind of light that has this kind of shape, like this. I don't know why, you might just want this. So, given this, and given some kind of a surface, maybe like this. Now you would like to have this light on here. And the way you do this is very simple. Essentially what you do is you render the light as geometry onto a blank texture. So you do two geometry rendering passes. The first one, you simply render all the lights onto a texture. And this means you can just render them like any other object would. So you can apply textures to the coordinates, you can apply transforms and skews and whatever. So this is exactly the same. All you do is just render the lights as geometry onto a separate texture. And then when you actually render your standard geometry, you simply use that texture as an input to calculate the effective color of the geometry at that point by mixing together the light color from that buffer. So you're still doing some work in the fragment shader, which is looking up the current point in the neighboring texture to find the lighting color, and then you mix the two colors together and output that. But that's a lot less work. It's essentially, typically just one memory lookup plus maybe an addition or a multiply versus many complex matrix operations. So it should be a lot cheaper, and because we're rendering geometry, we can make use of everything else we've done before. We can apply textures and other kinds of shader effects much more easily. It should also be much easier to get going since we don't need any complex uniform buffer objects or anything like that. So that's my idea. Obviously, this only works for 2D because in 3D you don't have volumes. You can't render volume data, so you can't use this kind of approach. But in 2D, since we only have areas, we can perfectly do this with no problems at all. Okay, I hope that's clear. So let's also put some music on. Here we go. If the volume is correct. Kind of. Okay. Good. So, first of all, we are going to, well, we're mostly going to just nuke everything. In here, yep. Almost everything, that is. I do want to leave the light environment class in, or do I? No, I don't. Never mind. File annihilated. Okay. Before I do any more, I need to go in here, do that, and remove the GI. Okay, also need to fix up the world region space data. There we go. Okay, now we should be completely without lighting. Watch. Crash. Interesting. Vertex form. Thought I fixed this. That's an older bug. Maybe not. Or maybe I did somewhere else. Don't know. Right, I forgot to remove that as well. Light identity, and I believe... Where else was that? Just gonna remove all of that stuff for now. Come on. Oh my god. Please. Oh my god. Where is that? That is... We are gonna need something very similar to this afterwards anyway, but for now I'm just getting rid of it. Please work. Thank you. Not quite. Something is wrong. Where is activate called? Okay, we're good. Hooray. Except for the crawling issue, which I never fixed. That I don't understand. Okay, well, anyway. Alright. Let's get in here. So the way things work in this is that we're going to create an additional pos. So we're in the way things are orchestrated in trial is that you have a sequence of objects and a sequence, well, not a sequence, but you have a scene graph of objects that represent things to be drawn, and you have a sequence or a tree of render passes that should be performed in order to actually render these objects and their effects and stuff. And the way you compose this is you create a tree of these render passes, and you define exactly what kinds of inputs and outputs each pass has. So that's textures and buffer objects that the render pass requires, and textures that the render pass produces. And then during your pipeline construction, you tell it exactly which textures belong where, so how these passes connect together with their inputs and outputs. And based on that information, it does a buffer allocation, so it allocates the exact number of textures that are needed, minimizing the amount of memory you require for that, and it computes the correct sequence in which to render these passes. Then it also computes which objects should be drawn on which pass and how, so it does shader combination during that time, and all that sort of stuff. So the way we're going to do this now is we're going to define two new passes, one being the lighting pass and one of them being the standard rendering pass, which takes the output of the lighting pass as an input texture and then uses that to compute the colored values at that point. For a very simple way of doing things in the beginning, we're simply going to add together both colors, so that should allow us to just see that the light appears at all, and after that we can take care of, you know, doing actual color mixing and stuff in a more sensible manner, so that's not just, you know, adding together two textures. Okay, let's get started. So first we're going to define our passes. Define shader pass, lighting pass, and this is going to be a per object pass. Actually, it's gonna be a render pass, really. No. Can't just be a per object pass. Let's leave it at that for now. And this is going to have a... Let me actually quickly look at this again so I get a refresher on how it works. Is that reduction pass? Yeah. Okay. So... port type output text spec. What was it? 2D, and we want a float texture, so we specify, what do I specify? I forget what this is called. We can use an HDR. Actually, we can use an HDR output pass. Correct. Yeah, let's use that instead. But it is also per object pass, so that's fine. Okay. Fine shader entity. So we're gonna have a vertex entity. What is light defined for? Is it not? Ah, it's a deferred. Let's just shadow that for now. Okay. So now for the lighting pass, it's important that we don't actually render any of the objects that aren't lights, so we're gonna need to take care of that. Well, let me see. Register object. So there's a couple of functions that are involved in this protocol. The first being register object for pass. This function takes care of letting the pass know that this object is going to be rendered with the pass. As part of this, it's going to compute the effective shader source code of combining the passes shader source snippets and the object shader source snippets, and then allocates...
Want to mention, last times when you worked on Leaf, I had a feeling that everything is possible.
Did it crash? Why is TTS choking? What the fuck? Oh, I think it's getting confused by the line breaks. Okay, sorry about that. He further says, like when you play Minecraft for the first time, if you know what I mean. Before that, I thought of it anemic, constrained versus your normal platformer. It reversed. Yeah. Thank you. I think that's a compliment. I'm not sure, but yeah. Software design is so open-ended. There's so many things you can do. It's hard to know where the limits really lie. Sometimes, especially if you really know what you're doing. So it's yeah, cool stuff you can do. Anyway, letting pause.
Yeah, it is. It feels and more story-driven.
You mean it feels more than story-driven? Or... huh?
no.
Huh? I don't understand your sentence then. It feels then more story-driven. Huh?
It is a compliment. I find the concept interesting.
Yeah, I'm just not, your last sentence just doesn't make grammatical sense to me, so I don't know. Or, huh? I'm confused about what's being disagreed upon, about.
And I think it will be more story-driven than driven by mechanics.
Oh, okay. Yeah, probably. Probably. I don't know yet. It's hard to tell these things by how it starts out. I definitely don't want to abandon the platform mechanics or anything like that, but it's always when it comes to writing or level design, I just have no idea what I'm doing. Okay. I'm trying to find a particular method. Getting very confused. Hmm. That's Oh, it does this inversion twice. Okay, I see. Okay. Yeah, this was a bit confusing. Actually, I'm also gonna do it like this here. Lithing pass. No, lighting pass. No, lithing pass. Good. My endless barrage of typos is gonna get the best of me. Okay. So, this should ensure that only lights are ever rendered onto the lighting pass. Good. We don't actually need to do anything more than that, as far as I can tell. Next we need to define the rendering pass, which is going to be a render pass, and it's going to have the lighting as port type input. Okay. Render pass, I think, is simply defined as a per object pass with a depth and a color output. Yeah. Okay. Right. So now that we have these, we can quit this out for now, go into our main, and in our... where are the passes set up? Render pass. Right. So in setup scene, we now can build our pipeline. And we do this by creating these two passes first. Lighting, instance, lighting, pass. No. Okay. Turns out a neighboring cat has invaded our home. I'll be right back. Okay, sorry about that, I'm back. Not sure what the fuck, but an enemy cat decided to invade our home. Okay, back to this though. Okay, so all we need to do now is connect these together. So we connect the, I think it's just called output? No, it's called color, okay. Okay, connect the color buffer to the lighting buffer of the rendering pass, and that should be it. There we go. Now we should have the lighting pass run before the rendering pass and pass that information around. But we're not quite done yet. Let's also attach a shader that will automatically run on all the instances that are registered on the rendering pass. Oh, I also forgot. Of course, we need to ignore the lights for this one, so register object for pass, entity or light will simply do nothing, and paint with as well. There we go. So we're gonna be rendering pass fragment shader. Okay. And the priority is gonna be very low. That should ensure that it's being called lost. Okay. Our output color, uniform, sampler 2D lighting. That's our texture with the lighting information in there. It has to be named similar to the similar to the port name, so that it automatically picks that up. And right. So now we can mix that color in after we do the lookup, which I believe we can get via glfrag chord or something. I forget how to get the current fragment position. Yes, glfrag chord. Let's see. glfrag chord is an input variable that contains the window relative coordinate values for the fragment. Okay. Location 0505 is returned for the lower leftmost pixel in a window. What? I'm confused. Give me a minute. Oh, okay. So it uses viewport. That's alright. So we can use pixel addressing, which is actually nice. Let's see. 5vec2 pause is glfrag chord. xy minus f2 0.5. We shift it down like that, and 35 f2. And that's, and then we do color is added or pixel fetch, I believe. Let me check. Pixel fetch, lighting, pause, 0. Okay. Let's make sure that our shaders are correct. And how can we do that quickly? Compute effective shaders. No, not that. There was a function to do that with. I forget what it was though. There's a protocol. Make pause shader program. It's pause shader. So it's coerce pause shader. Rendering pause object. Let's say chunk. Why not? And the type for find pause chunk fragment shader. Okay, so here's the complete shader once it is combined with the rendering pause. That's our default rendering behavior. And then here we come in, we do that. It's our 2D task set. And we add it together. Okay, looks good. Looks good. So now I should be able to still launch the game. Pipeline is not consistent. Pass is not texture compatible. Huh. That's interesting. I need some more output information. Let's input S. Set up a scene. Fucking Christ. Okay, let me see why these things are not compatible. Hide with. Oh, one of them just doesn't specify the target. I don't see why that's a problem though. It's odd. Join text spec. Oh boy. Join texture format. Target. Okay. Wait, does normalized text spec just not... I think normalized doesn't do a proper job. List. Right? Oh. Okay. Another bug fixed. GL name with nil. Paint is never called. Paint with is not called, so this doesn't trigger. Huh. That's a problem. Why is paint with never invoked? It should happen. I don't see it in the trace here. Ideally, we wouldn't have to do this runtime checking and dispatching and all of that. Okay. Because it would just, you know, do it on its own. But it don't, so... Okay. Now, one of the problems you see here is that, because we just add the colors together, it's now much brighter, and that's because the clear color is set to be something gray rather than, you know, black. And so by default, this lighting pass is already filled with something. And this is a limitation in the trial engine. It can't currently deal with different clearing colors for different passes, which is rather annoying. Let me see. Where is the clear color? Set that to 0. And then we need to take care of not just adding this, but back for light. Not just adding the light, but also multiplying by the alpha value. So now we should be back to normal business. Good. Okay. Good. Alright, so now that we have the passes set up, we can start defining lights. And we can do that pretty easy, I should imagine. So, let's start by making a couple of lights. Define shader entity. Let's make this a located entity. Because why not? Point light. Did you play other games which had an interface mouse only, like Leaf? I mean, 2D side scrolls or adventure games with point and click, but it's not the same. I'm not sure what you're asking. Immediately, of course, I'm thinking of adventure games. Leaf doesn't really have a pointer mouse interface. It's only for the editor that it does. Oh my god. What the fuck? That's interesting. Oh, they're rendering as triangles instead of lines. Whew. Whew. Okay. That's something to look at for later. It's not really a point-and-click interface or anything. In the very least, you're not expected to do that, and I don't think it's gonna work like that. But rather, it's gonna be a controller-based interface where you can just walk up to things and inspect them, you know, like an RPG. I don't know why uncrouching is weird. Okay. I think the problem with the uncrouching is that it's, for some reason, it always detects a collision above her head. I don't know. Back to this though. Lighting is what we want to do. So, well, to be honest, pretty much all of the lighting stuff can have dynamic assets, so let's not make it point light. Let's instead make a basic light, or yeah, I guess so. Make a basic light, which is a light on a colored entity, which has a color, I believe, yes. Color form deck 4 should just be bright. Okay. We can also make the, I guess the defaults. Do I have a pool? Right. Yeah, I do. Okay. Define asset. Leaf. Sphere. Don't I have a thing for that already? I forget all the things I have. No, I don't. Okay. Sphere is a mesh. Make sphere. This is wasteful. Or wait, hold on. Do I have a make disk? Yeah, I do. Alright, never mind. I don't need to do that then. I'm still gonna call it sphere. Size is gonna be, I don't know, 100, maybe. Sure. Okay.
Yeah, I assumed that it is point and click, took that from the streams with a star.
Oh, no. That's just for the editor, not for the actual game. Oh boy. I don't know why it's rendering as triangles, that's real bad. Okay, anyway, let's start with other stuff first. Enter, make instance, basic light, scene. So now, if I reset up the scene, we get a light, and it's infinitely bright. Which is, you know, not what we want. So really, after doing that, we need to do an attenuation of the light. So an HDR reduction, essentially. Where was that? Trial, HDR. Tone mapping pass, right. So we can simply take this, that source color, and take this. Okay. Now things look real weird. The reason for that is assets that we don't specify these as what was it? sRGB textures or whatever. File. Helpers. Wait, that wasn't it. Helpers. What am I doing? File. Toolkit. Yes. sRGB. Let's first test the... There we go. That looks normal again. Normalish. Kind of. Light is still too strong. So let's reduce the exposure, I guess. Makes it darker. Of course it would. Still wish there was more attenuation in there though. Why is that lighting still so strong? What if I reduce the exposure even for... Just makes it darker, huh? I'll explain what's going on in a second, just give me a minute to figure out what I'm thinking. Confused. Let me try simpler Reinhardt tool mapping, which I can just copy paste in here. Your color. Shouldn't be so much brighter than everything. I don't understand why it's losing all that. I'm guessing it's losing the information of the floating points in here. So, okay, let me explain. HDR is stands for high dynamic range, and essentially what you do is typically when you render stuff, you render to, even though the shaders all deal with floats, so you have vector 4s of floats for colors. Internally, it's stored as integers, and it's clamped to the range of 0 to 1. So you cannot exceed that range. If you output a color that's outside of that range, it simply gets clamped inside that range. And that means you lose valuable lighting information. For instance, if we add something very bright to something else very bright, it just ends up clamped as pure white. And that's not what we want, because we still want to retain the actual color information of the value here, but that's not what's happening, evidently, for some reason. And I don't know why, because, yeah, should be the case here. So weird. Know why. This should be like, you should be able to see details here now because we're adding that stuff together. Oh, it was the alpha value? Okay.
IMO, using point and click is still worth a thought. What I said about that above still holds. It felt good in the editor, by that the player is freed from the low-level movement mechanics.
Yes, but I still want to make the movement mechanics a central point of things. I do very much enjoy platformers, and I would like to design levels with that platforming challenge in mind. So, yeah. Alrighty. Okay, let's go back to this. Reduce the exposure a bit. Let's put it to 1, maybe. Okay. Right. So, with that mistake out of the way, now we can actually see it in action, which is cool. So, this light that we are rendering here, the circle, is pure full 1.0 light. So under normal circumstances, this would just be a flat disk as we saw before, but using a HDR tone mapping pass, we can get this color to still show through, and this works by using, well, in this case, an exposure level and a gamma curve, and the gamma curve sort of non-linearly adjusts the colors to fit into a tighter space. This, of course, also means that the rest of the colors end up looking very different. So if I, for instance, comment all of this out, not like this, but like this, then, okay, well, you don't see it well right now. Not like this in any case. But it's, if you remember from before, it's looking a bit brighter, a bit less saturated. And the reason for that is this tone mapping pass that's shifting the colors slightly. The reason for why things look so weird when I completely disable the lighting is because now, in order to support HDR, we also need to take care of actually loading the textures we have with gamma correction applied. Otherwise, we will get double gamma correction, and that would look weird. So, RGBA. So now this is how the surface looks normally without tone mapping. But if I activate the lighting again, then now it looks way too bright. So we need to do this mapping to get it to almost be the correct thing again. It can't be entirely correct, of course, because of the benefits we get with the lighting in exchange. Okay. HDR is very nice for lighting and making things fit better because we need to twiddle less with things. Right. Okay. So that's the lighting engine. We're done. That was it. And now we can draw anything we want as a normal entity. Move it around. We can even make it spin and things like that. However you like. Cool. Yeah. Of course, that's not quite done yet. There's still stuff that could be done from here. For instance, making gradients and stuff inside the disk. So, hold on. So we could try to do this. Life, gradients. Color verdicts, I believe this is what we want. Variable mesh is unbound. What is happening? Oh, Oh my god. Oh, right. Segments is on too. The geometry construction functions in Trial are they leave things to be desired as well. Okay, let me see if that works. What was that? Per vertex. Please work. Didn't work. God damn it. Why? Unhandled memory fault. Amazing. My favorite. Don't know why it's not showing up. By all accounts, it should. Doesn't this... Huh. Weird. Wait, maybe the... Yeah, location is set to 2 instead of 1. There it is. Yay! We got a radial light, gradient light thingy. Smooth. Cool. Yeah, we can now do this for textures as well. If you would like to. It can generate the correct UV coordinates and shit like that. So let's actually do that. Let's draw a quick texture or light. Krita. Boop 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 doop. No, actually, let's make it just like 128 by 128. Please. Please. Okay. I want to make like a flashlight kind of thingy, so let's create a gradient that's cool and shit. I guess. So, make it slightly yellow. Something like that. Okay. Wait. Fuck. How do I delete stops? Please. Oh my god. Press and delete everything, nothing works. Fuck. Oh, you can just drag them out. Okay. Makes some amount of sense. I just... no. Okay, there we go. Now I just want to vary the opacity at several levels. Be very bright. And then stay. Just reduce it a bit. And then very low. Maybe not that low, but pretty low. And then another one. Okay, let's see how this looks. Okay. This is pretty flashlighty. I mean, it won't look any sensible at all in, you know, 2D, but I just want to see the effect in general. In fact, let me just draw something more sensible for our scenario. Maybe like something like can't snap. Bad. Bad program. Do something like this. And then let's use a linear gradient. Looks like shit. Okay, I guess. Okay. Yeah. Nearest neighbor. Okay. It's a test anyway. PNG ping, as I like to call them. Leaf. Leaf. I need a new name for this game because leaf is about as unfitting as potato. Data. Zoid. Is it actually with transparency now? Don't know. Trapezoid. No, it's not. Bad. How do I save it with transparency? Export trapezoid. Yes. How do I get the fucking background gone? Image. Which background? Alpha 0, please. Okay, there we go. Good. Hey, there it is. Good. Okay. So, define assets. Thanks. we go. Textured white. See it happen. Go. Crash. Bird series unbound. Oh yeah. Hey, there it is. Looks like shit. Let's see if we can't improve that a little bit. Min filter nearest. Filter nearest. Slightly better, but not great. I think that's actually how it looks on the texture, as in like shit. Why can't I select the light though? I guess it doesn't have an extent. How does it do the thing with the thing and the thing? Contained P entity at point. Base entity. Sized entity. So I guess I can just make this a... This is just a crutch, but... Yeah, there it is. I have selected it, but I can't move it. Enter. How did I move things? I think, yeah, there it is. Cool. Okay. Sick. There it is. Let me make this a bit less garbage. Hello, execute. This does look like a heap of trash at the moment. Should probably have used Asprite, to be honest. Yeah, let's do that real quick. Open door. Because now it can actually even show me the grid. Nice. Let's do that real quick. God damn it. I really don't like its polygon selection thing. For some reason you need to drag the edges instead of just fucking clicking. Okay. Good. Actually, let's make a Deferred. That means full shit look. Save that up. And load her in. There it is. Probably make it 1 notch shorter. There you go. Doesn't look very convincing, does it? Just need to soften the edges and it'll be good. Maybe not quite like that. Something like that. There you go. Okay, cool. Well, new lighting system works. And the only problem with making it directly textured like this is that obviously, you know, I can't make cool things happen like rotating it or whatever. But what I can do to help with that instead is to, you know, use as many polygons as possible, so make things out of polygons instead of just straight textures on a rectangle. Because then I can rotate it and things. What I would like to do is to change the editor so that I can actually draw the polygons I want, so that I can just say like, here's the origin, here's a thing, or just start clicking points and it'll snap me to the grid and it'll draw me that light with that polygon stuff. And I can do that pretty easily, I think. So let's see if I can't do that pretty easily, I think. Okay. First, let me get rid of this stuff. Light, I'll need that. Well, I guess I'll just leave it in for now. I'll be very happy once I actually have a proper UI for the editor, and we're getting very close with Alloy for that, but we're not quite there yet. So let me make an impromptu key. Kludge this key. Make light. Press F8. Okay. Now let's create a new editor entity. This is stuff, text input topic. Find shaders subject light creation editor. Don't have a... yeah. Probably also going to define all of the things as a fan. So it's going to all just be vertex form, triangle fan. I forgot everything. Size 2. Offset. No. Start, I believe. 8. Stride 8. Buffer, data usage. What are the three things? There's 3 different properties, and I want to use one of them. One I've never used before. Don't have a thing for that in trial. Toolkit, stream draw. Yes. Dynamic draw. enter T. Allocate VBO. Allocate VAO. Okay, and now size is going to be 0 for now. What was it? Mouse click or whatever. Mouse press. Define handler. Rights creation editor. Vector push extend. Got 10. Good. Yes, pause. Essentially what I'm doing here is whenever I right click in the editor, I record the current mouse positions as that is not at all what I want. I record the current mouse position into the vertex buffer and then update it to upload to the GPU, and that should give us nicely rendered things. A preview of what's to come, essentially. Once I figure out how to work this stuff. So once we have 6 polygons or vertices, once we have 6 in the ZF size AO. There we go. And now I need to add in the thing. Find handler, editor, make light. What was the keys? Yes, that was that. Good. EV change class editor, light creation editor. Okay, let's see it crash. Editor, make light. Don't know how to convert T. Right. I forgot, of course, to make the element type single float. Don't abort. Abort. Allocate. Expected offset. Fuck me. Come on. Work. No. No geomain. Why not? Right, because I haven't done things. Still need to register the object. There we go. Light creation editor. Okay. That's not what I wanted at all. Doesn't seem to be working. Or in the very least, I can't see shit. Why? We're almost at the end too. Blast. Print. Okay, that's not doing it at all. Is it not even this? It is. Oh. I'm an Angleberry. Call this data pointer. Closure? What? What do you mean? sources, vertex, buffer, buffer object. Buffer data. Should probably call resize buffer instead. Don't. I love me those. It's almost there. No. Fuck me. Oh, I know again why this is happening. It's using the... Is it? Yeah, I think it's using element drawing when we don't have an element buffer attached. Annoying. Very, very annoying. Horrible clutch. Not seeing it. Wonder why. It does exist, I just can't see it. Should have at least some amount of, should show up as white, as far as I can tell. But it don't. Why? Oh, there it is. There's something. Huh. It's adding triangles. Much, less quickly than I expected. Weird. Why? Yeah, this is bizarre. Well, yeah, I don't have time. I can't go overtime today. But let me just annotate this. Fix me, broken. But the actual, lighting system is in place mostly. There's still a couple of things that need to be done, namely, actually checking whether we're in a background or not, instead of just plainly mixing things together, and doing some stuff like that. And then obviously editor support to make that much better, so we can make some moody environments and stuff. But yeah, the essential idea of the lighting system is in place, and it works, and I'm pretty happy with that. New lighting system, mostly complete. Okay. Well, that'll be it. Thank you guys for joining, and see you tomorrow again. I'll try again to do this day late, but we'll have to see how it goes. I'll also consider doing a writing stream, building stream, and yeah, we'll see. Good night for now.